question number 33 is maximizing a value problem. And this one is really interesting because what ends up happening, if you look at my graph here, you'll see when it's over, what ends up happening is we actually get a cubic function, and we are going to maximize. We have a maximization problem, right? It's this maximum right here, but it's going to be a local maxima because obviously there's a minimum here, so it's not just your basic quadratic where you only have one minimum or maximum. So don't forget that that's going to be happening. The question out of the book says, a square of side x inches is cut out of each corner of a 10-inch by 18-inch piece of cardboard, and the sides are folded up to form an open-topped box. Okay, so that's what I did right here on each side of my rectangle, where one side was 18 inches, right? The longer side, obviously, and the other side was 10 inches. Okay, I cut a little square out of each corner just because even though it's not in our DSEA, I find it really hard to do problems without actually drawing them out. Okay, so what's going to happen, and I wish I could draw this here in 3D, but what's going to happen when you fold that up, fold each side up, x is going to end up being your height. Okay, if you fold up each side, you're going to fold it up to be a height of x. I put that here. H equals x. That's going to be my height. My length, right? My length, which is going to be my longer side, was 18 inches, but now I'm going to subtract here. Okay, I'm going to subtract 2 of those x's because I have to take out this x and this x. So what's going to happen is that my length is going to end up being 18, but minus those 2 x's, and the same thing is going to happen to my width. So my width is also going to be 10 minus those 2 x's on that side. Okay, so the area of my volume, are you kidding me right now? So the formula for the volume here ends up being, it's the length times the width times the height, right? My height is x, my length is 18 minus 2x, and my width is 10 minus 2x. Now I just went ahead and put that into a graphing utility. I used my iPad. And this is what it turned out to look like. Now, the question before this one, I think it's question B, asked for the domain. And the reason it's asking for the domain is because it wants you to have that local. It knows there's going to be more than one maximum or minimum, so it wants you to know which one to use. And as you can see, the domain is from 0 to 5. And the reason it can't be, it's a curved parenthesis, so it cannot be 0, and it cannot be 5. It can just be what's in between them. And that's because if it was 0, if x was 0, that would mean it didn't have any height. And if it doesn't have any height, how can it have any volume? That's a little bit nuts, right? And it can't be 5 because if it was 5, if you go back and look at the width, that would give you a width of 0, right? And you can't have volume if you don't have width either. So that's what makes the domain. That's one of those weird domains. It's not a radical. It's not a denominator. It just doesn't work in the real world situation, and you also have domains like that. So, and I went ahead and found the maximum right here. So the maximum volume is going to be where x, each side of that square is approximately 2.06 inches. And that makes the maximum volume right here. I think it's like 206 if I can read my writing there.